Can you describe the... Continue.
Okay. The thin client is only required to provide...
Start again.
Oh, man.
Okay, we're here with Scott Johnson of SolarNetOne. Scott, can you tell us what is SolarNetOne.org?
SolarNet1.org is a project that we started around 2005, 2006, somewhere in there, to bridge the digital divide between developed nations that have access to information pretty much everywhere, and the undeveloped nations with no power grids, no communications infrastructure, that don't have access to the kind of information we have with the internet on a daily basis. And the goal of the project was to bridge that divide in some of the most remote and difficult to deploy in locations in the world.
Okay, and what does your R&D lab produce?
Well, we've produced thus far several advances in charge controller technologies. We've done quite a bit of research over the past 3.5 years into several alternative energies far beyond your standard photovoltaic application of solar power. But our original effort was to develop the necessary equipment to go to these remote places in the world and provide a stable, secure, basic internet service provider package that can be used to introduce the people there to the internet and to the modern world and the things that are possible because of it. So we developed a very efficient computer network that is designed to run completely off solar power, and one of the main challenges therein is getting the efficiency of the network to the level that the solar power array and battery array required to run it, it has a low enough cost to be a feasible option for many developing nations or even independent businesses, government installations such as park services and things like that, emergency recovery situations where you would have the system in a short shipping container ready to go to be dropped into an emergency situation with a helicopter to provide satellite uplink and wireless services and terminal services right there. So we designed all of this to be very, very power efficient so that we could shrink the size of the power supply. We wound up using about 700 watts of solar power panels, which each of those panels, you're looking at about 8 panels generally, of somewhere in the neighborhood of 2 feet by 8 feet, or 2 feet by 4 feet, sorry. And we go from there to a breaker assembly that it isolates each panel. We go from there to a charge controller system that regulates the flow of energy into the battery so that we don't wind up with an overvoltage coil situation. We charge up a large battery array, and then we run our loads off of that, directly off the 12-volt DC. That previous statement is really the innovation that allowed this project to work in a great many places, because we eliminated about 40% of waste normally associated with solar power deployments, whereby you have some kind of inverter coming off your panels, and that goes into your grid, be it a local grid or the overall grid, and then it gets stepped back down again, coming out of the wall into your electronics. We cut the middleman out there and lost about 40% of the heat waste that's associated with those conversion processes. So in order to make this network a viable option economically, as an architecture, we had to find the greatest efficiency, and that's been our focus of all of our research since the inception of the project. As each generation of the system has unfolded, each piece of equipment gets more and more efficient, or provides more features for the same level of power. The research that we've been doing most recently has been to drive that efficiency even further. And at some point, I think we could probably do away with the photovoltaic panels altogether and simply use a magnetic interaction with a larger flow from the sun that's always present and passes through everything to harness the energy that's necessary to sustain the operation of these networks. And that really opens up whole new latitudes, literally and figuratively, as to what we can do with these systems.
Okay, can you describe the process which powers the SolarNetOne and the services it provides?
Well, sure. The process starts with the sun, actually, where we have a wide array of light, both visible and invisible, streaming at us 24 hours a day. Now, it only hits the day side half the time, and depending on the latitude, more or less. But we collect the photons that are coming from the sun. And one major improvement that can be made there is to increase the frequency band that the solar array works on. The photons strike the solar panels. They excite electrons in the solar panels. The electrons create a charge that's carried over individual wires down to a breaker assembly that isolates each panel from the others. That's carried along larger bus-style wires to the charge controller and another breaker assembly, which isolates the panels from the batteries, from the loads. So in case there's a failure in any one component, the entire system isn't compromised or otherwise unsafe. The battery array collects the energy during the day. We design the system so that we have, say here in Florida, I designed it for 6 good hours of sun a day per average, or on average, across the entire year. Now we get a little more than that, so I get a little more output, but it's always nice to undersize your array so that you make sure you never run out of power.
And this SolarNet system is not just a computing system, you're also charging lights and phones. Does that run off the batteries, or does that run off the hub, or how does that work?
The system will run off the batteries, yes. We have a distribution block bus bar system that's at the main server case, and that distributes power to the terminals, to telephones, to lights, to motors. I have several other buses running off the prototype system here to different workbenches.
Okay, and so you're not just setting up internet service, you're setting up a cafe with the actual lighting and everything. And
There's
phone
lighting.
service, how does that work to integrate phone service with the SolarNet?
Well, the phone service is like any other voice over IP service.
And can you talk about the difference between how a SolarNet connects to your power system versus how another computer system connects to the grid, or another computer system connects to solar panels on a house or a building that is
Sure.
tied into the grid?
Sure. In a grid situation, the grid was designed for limitless, cheap energy, kind of a dream that we now realize is not a possible thing with the technologies that are currently forward. So we could always throw more coal on the fire, and that was the theory. So the grid provides you with distribution a long distance from your power source. So you have a power plant that's a coal plant or so. So you keep shoveling your coal, and that runs the generators. The generators pump electricity down the high voltage lines that you see tracing across the country to your local town, where they come in through a pole or underground to your house and out to your wall. They use high voltage alternating current because it has less losses in those long transmission lines. However, when you're generating power locally, that's not really a necessity. So it enables us the possibility to bypass that portion of the system and see efficiency gains as a result. Don't get me wrong, I'm not knocking Tesla's AC system. It's a beautiful way to move a lot of electricity, but we can't organize things that way anymore to be self-sustainable. So in order to do that, we would, say, want to run solar panels on our house. Okay, fine. Now we have our computer system in the house. Our computer system is a standard PC computer. It draws about 200, 250, 300 watts from the wall. When you add the numbers up, you realize that it's going to take you about 240 square feet of solar panels just to keep that one computer running 24 hours a day. You realize there's got to be a better solution. So that better solution comes by choosing the hardware that is most efficient, designing hardware to be more efficient, and implementing that in a fashion with the least loss and waste in the system. That means cutting out all the conversions in the middle from the DC, direct current that's coming from your solar panels, to the direct current that's eventually being used in your computer once the power supply is done spinning heat out the back. By eliminating all that, we eliminate the heat waste. That saves us about 30 or 40%. So that's how most people would do solar with computers. The machines aren't efficient because they haven't had to be, and they're not designed that way. Off-grid solar or on-grid solar, doesn't matter. You have your panels there, you still plug your equipment into the wall in most cases, and so you're still going to have your conversion losses. On-grid solar, okay, you have to transport it back out to other people, that's fine. But if for off-grid solar, there's no way that you want to have to use inverters and waste 30-40% of your energy in conversion.
Are other people who are building solar networks, solar computing systems, are they running their systems directly off of direct current, or are they still using the direct current to alternating current to direct current configuration?
I've only seen one group even attempting to enter this market, and they were still using the conversion method you just described that wastes about 40% of the power.
So this is highly significant.
Well, absolutely. The real goal of the project is to push computing forward, you know, as a secondary goal there, to push computing forward in terms of efficiency and adaptation to the changes we see in the world and the changes we must make with our civilization to adapt to those.
Okay, so technically speaking, what do you actually do in order to cut out that AC circuit?
Well, once you take your computer apart and look inside, you'll see that the output big gang of 24 or so wires that's an ATX connector that plugs into your motherboard is actually carrying ground, 5 volts, 12 volts, 3.3 volts, and etc. And it's all low voltage DC that's actually being carried onto your motherboard. So the ideal method is to simply remove that component. Since we start with low voltage DC in our battery array, instead of going to inverter, then power supply and computer, and back down to low voltage DC, we go directly from here, and we put in a small voltage regulator or a step down to ensure that when our batteries are charging at full, they can reach, 14.5 to 15 volts. And we don't want to pump that much into our rails of our computer, so we put a small regulation circuit there that makes sure we have the 5, 12, 3.5, and etc. And that'll allow you to convert a good amount of the equipment. Any computer that uses, or any piece of equipment that's already very efficient that uses an external wall wart plug to provide its 12 volts has an internal regulator in it. So you don't even need to take that step. You can just wire it directly in. We've chosen that method many times concerning displays and other devices where it would be a very simple conversion without even opening the case to do so.
How do you manufacture the solar net?
Well, I wouldn't say that we really have a manufacturing process. We more have a craftsman's process. I collect data from the proposed deployment location currently and determine the needs of the system from that and implement the necessary technology to order. So, for example, if we know we're going to have our desks in a certain place, I make the wires fit to those desks with just a little bit of extra slack. We save shipping costs this way as well as with waste, and we do much better in terms of fitting the system. I'll generally start with whatever off-the-shelf components are required. Sometimes I'll have to craft and have custom-made components done or handcraft some components, but generally I'll go with whatever off-the-shelf that I can use to efficiently and effectively do the job. Of recent, we've been doing a little more into custom tailoring our server and client architectures, and that'll be rolling out in the next version. But needless to say, we're going to see a power efficiency gain of about double what we're at now. So 50% cut in power usage, which will mean a 50% cut in power supply size.
And is that from the next version compared to the previous version, or from your first version?
That's compared to the current version. The original version, we've already cut it in half since then, and we're preparing to cut it in half again through some custom boards specifically to our specifications.
Great. Okay, and what is the efficiency of the SolarNetOne as compared to similar technologies?
Well, I don't know that there are very many similar technologies, but we can group that into something along the lines of a computer seat where someone sits and uses a computer. Okay, it works out that the current SolarNet, I can run 5 of those seats and a hub, a long-distance wireless access point, the server, and a couple of lights and things for somewhere along the lines of 80 or 90 watts. Over 24 hours a day. It's very easy to do the math and multiply that out. That we show how many watts we use per day. And when we do so, we realize that just one personal computer, in comparison, running in a standard fashion, is going to use between 100 to 300 watts, depending on its usage level, during that same time period.
Okay. Can you please describe the battery array and storage characteristics?
The battery array and storage characteristics, sure. We like big battery arrays because we like 5 nines of uptime on our power supply.
What is that?
5 nines means 99.999% reliability. Okay, and that means that you're only going to be down for a couple hours every year at maximum. And we've actually far exceeded that. We've had years and years of uptime without any disruption to services whatsoever. In fact, since the system went live, I've never had a day when I couldn't run the system. So we use generally anywhere from a 1200 to 1600 amp hour battery array. That is going to store enough energy to run the server in emergency mode for about a month. If the panels blow off the roof, or they're stolen under attack, or any other similar type of crazy scenario that may come up.
Okay, and do these batteries require distilled water?
They currently require distilled water. Back to the other system, for a moment. We get about a week of uptime if the panels blow off the roof with the entire network running. So that gives you a kind of an idea of the storage capacity that we have on the network and what we can do in the event of emergency to keep systems up and running. The batteries array does require distilled water. I chose vented lead-acid batteries because it comes down to watt-hours stored per dollar. If we use sealed batteries, it costs us about 4 times as much. If we use lithium-ion cells or something along those lines, it costs us 4 times that. So a 16-fold increase in cost, that may not matter to NASA when we start sending these systems to the moon, but when you're sending it to a remote island nation whose primary activity is subsistence fishing and coconut harvesting, you really can't try to slap lithium batteries in there and put the price tag on it.
Are the lithium batteries the ones that don't require water?
Lithium batteries don't require water. Sealed lead-acid batteries don't require water. However, they're not going to last as long as a vented lead-acid battery either. Further, when using a vented lead-acid battery, as long as we're able to maintain our batteries to a level of not having any warping in the plates, we can counteract any sulfation that occurs in the battery to restore it to a new or better than new condition through occasional service through a device designed specifically for that. Maybe.
Okay.
Yes. Yeah.
What unexpected challenges did you face when setting up the SolarNet?
Oh, the trials and tribulations have been great and wide and varied. In the beginning, of course, we had technical challenges to overcome with the prototypes, matching voltages, making sure that we had our numbers right. programming relatively new devices with GNU Linux so it ran properly and provided the functions that we needed. Yeah, those were those kind of trials and tribulations. But then you run into things like international shipping issues, where you have a shipment diverted from its port of call in Lagos, Nigeria, as it's headed for Kisana State University in northern Nigeria, diverted for a year to, where was it? Frankfurt, I believe it wound up hanging out, until we finally tracked it down and forced it to be delivered to Katsina State. We had a box disappear on the way to Christmas Island, routed through Hawaii. Just disappear. It was tracked with a dozen other packages, and it just disappeared. Well, we tracked that one down too, and made them return it, and it finally made it to the boat and to Christmas Island.
Yeah, I highly recommend insurance with signature confirmation.
Oh yes, absolutely. It was critical to solving that problem. Let's see. We've had monopoly telcos that were providing service from Australia to target locations where we were installing systems. Essentially, denial of service to the entire island, so I couldn't get any data in and out, and I had to. The way the satellite link was set up, there was a router on the capital island in Tarawa, and there was a satellite bounce off Intelsat from Christmas Island to Tarawa. So the blockage happened in Tarawa at a router that was owned and controlled by Pactel, the telephone company that's been providing service and also provides a competing RIC system, which is little more than 2 PCs, a wireless router, and some solar panels. So.
And how does that compare in terms of cost? Yeah.
On the solar array?
Well, I mean,
you need a massive solar array. The cost is exorbitant.
So, like,
the cost of the satellite service is exorbitant. It costs almost $2,000 for a 128K duplex circuit to Abemama, the first island that I lit up in Kiribati. So, back to the Battle of Christmas Island for a minute. Let me get this story out. So,
wait, can you please explain, because it's not clear to me why the other company is even interested in blocking.
They want to maintain their service monopoly there because they provide a mediocre service at an exorbitant rate.
And
I mean, that's enough motivation for any corporation that I know of.
Specifically, how much more are they charging for their services compared to what you were charging or providing to the telecom company in order for them to provide those services?
I provide the equipment not much above cost. I don't take much at all for my labor when I go out there. They get billed in full for every technician that shows up. And I believe they want to lease them the equipment at a rather higher rate than allow them to purchase it. And then charge them for any damages and things that may occur as well. So this router that's owned by... Well, so we have other challenges that we face as well. Like, for example, we had a satellite service provider. Now, I made it a point not to really include satellite services with the SolarNetOne because I didn't want to lock anybody into any provider. Well, this particular company provides service to many of the islands of my customers. And it's at a rather high rate, higher than market as I would estimate it, and much higher than what is available through various assorted other entities. They also provide a competing remote island solution, which is a little more than 200 meters, a wireless router, and a rather large solar power array with an undersized battery array. So, upon my arrival upon the island and the beginning of construction of the SolarNetOne network on Christmas Island, we began having problems with the circuit connecting to the internet as a whole dropping out. I did a little investigation and found that our route, which was simply a satellite bounce from Intelsat, ding, ding, back down to the other island, was intact to Tarawa, but that the router that was owned and controlled by the competing entity was no longer providing service through to the public internet from the circuit that was feeding Christmas Island. This means that either someone inside there sabotaged it, or more than likely someone remotely changed the configuration of this router to perhaps make it appear that I shut the island off or something. I don't know, or that this was somehow related to me. In any case, I continued building my network and found the path around this. I got on the telephone to Tarawa, to one of the technicians that I had instructed a couple of years before in my visit there, and had her construct a router from a personal computer. She brought it online with an IP address that I could reach. I then logged in, configured all the necessary functions so that we could route around the blockage and restore service to the island. This was particularly important actually because elections were happening at the time, and there was no way to get any information in or out concerning the election results on the other islands, the other precincts, and provide results from Christmas Island. So I found myself, after bypassing this blockage that was installed by this competing service provider, climbing a radio tower in the middle of the night to attach a wireless 2.4 gigahertz CPE to their tower, pointing at my tower about 5 kilometers away, so that they could actually report the election results officially to the Capitol. It was really a striking thing to realize that I was the individual responsible for allowing the flow of democracy to continue at that particular point in space and time. I was really overwhelmed at that point by perspective.
So, now that you have provided internet service and voice over IP service to these islands in Kiribati, what impact has it had on the community, and who are the people able to connect with now that they have these types of services?
Well, previously, even making a telephone call from island to island was very expensive and not a communications option that was in reach for the majority of families on a regular basis. So if you have relatives on the next island over, you were essentially cut off with them, just like these people have been for several thousand years. Without a short boat trip, they're just not talking to their relatives. After the installation of the systems and the build-out that has happened around the installation of the infrastructure, it's now commonplace for inter-island communications and expanded trade to happen between the islands, because now there's a better line of communications other than an RF link at the airport to make a reasonable communication, notwithstanding that RF link is not open to the public. After I installed the main transmitter and network system on Abe Mama, which is the ancestral capital of the Gilbert Island group, while I was there, I became friends with a man named Don Tokataki, who's a prominent man among the community in Kiribati. And in my communications with him, I was able to, make voice calls and video phone calls and things that he had never really, had available to him. And he wanted to have these things in his home. So I sent him a solar panel and a battery and a small charge controller and a wireless CPE, essentially as a remote client unit, so that the network could be expanded out. And he was able to raise the antenna properly, pointed at the main transmitter. Everything was configured already. He plugged in his laptop, and he was Skyping, and he was Gmailing. He was doing all of the things that we generally expect a worldly person to do, as he is. But he just happened to be in his home in a very remote place where this was not possible before. Since then, there's been a great expansion of tourism in the area, including several new hotels being built, the surf tourism and nature conservancy tourism industries being built around this, and we're seeing actually changes in the way that the native industries are happening. We're seeing the further refinements of coconut oil to fetch a higher price for organic grade A coconut oil, virgin coconut oil in the market rather than cocoa. The flow of information is increasing their economic potential, and it's improving their way of life and their communications with their families and others.
Hold on, I'll ask you something.
Okay.
what does the next generation of SolarNetOne look like for larger scale solar installations?
Well, the way I see that looking is kind of a return to the old school Unix concept where we have a little different architecture but the same kind of modular pieces. Say we have a row of edge connectors, and into these edge connectors we can plug in processor memory or disk modules, for example. Now we can have as many processors as we need online running parallel multiprocessing, each of these running their own instance of a net-booted operating system. And that allows us to save even more power because we can scale the computer dynamically in real time to the load that's required. So we may have 32 physical nodes online, but if we're only using 5, then only 5 are powered up. If our load spikes, then we can have all 32 nodes available.
Are you talking about a clustered supercomputer?
Yes, I'm absolutely talking about a clustered supercomputer, a solar-powered clustered supercomputer that runs on the most efficient hardware that we've designed yet on this planet that I know of. Maybe we have something better, but I might not have security clearance for that. I don't know.
And what architecture would you consider using for...
Definitely leveraging the ARM processors and the ARM architecture for that. We're doing a Linux load balancing algorithm to scale out the processes to nodes as one node becomes saturated and another comes online.
So, if you wanted, say, a 20-node clustered solar-powered supercomputer, how many watts would that be, and how much would it cost?
Well, ideally that would be about 60 watts, and if you're talking about 20 nodes, it depends on the form factor that you put it in. One can easily acquire the necessary development boards for the ARM architecture for, about $100 or $150 a piece. So this is the kind of thing that a person could just build by buying components from Seed Studio or eBay or the similar types of outfits. Ideally, it's not done that way because those boards have all kind of extra stuff on them that's not required for this particular application. Ideally, we take TI's OMAP 5, we slap it on a board with a couple other little pieces and parts that can provide gigabit Ethernet and some voltage regulation and things like that to us, and then we just start clustering those. Most of the code has been done for almost a decade. It just needs to be slightly forward-ported and tweaked, which is, in all honesty, for 3 or 4 skilled programmers, just a few months worth of work.
What